Timeless concepts from Physics Helpline. In this video tutorial, we will discuss a multiple choice question taken from the JEE Main exam of 2022. The question is based on the reaction forces acting on a ladder placed on the floor and leaning against a vertical wall. Read the question carefully. The names are not marked in the question. We have done it for better understanding. This naming of ABC. A ladder AC is leaning against a smooth vertical wall AB. Ladder AC, smooth vertical wall AB. The length of the ladder AC is equal to root 34 meters. And its weight is equal to 10 kg. Foot of the ladder C is at a distance 3 meters from the wall. Therefore, BC is equal to 3 meters. Reaction force of the floor is equal to FF and that of the wall is equal to FW. We are required to find the ratio FW by FF. Take the value of G is equal to 10 meters per second square. The options are given in the question. We are required to find the correct option. Now for the solution. We have retained the options given in the question and also the data given in the question about the situation. Now here length of the ladder AC is equal to root 34 meters and BC is equal to 3 meters. Mass of the ladder is equal to 10 kg and acceleration due to gravity is equal to 10 meters per second square. Now let us find the length AB. AB is equal to root over AC square minus BC square is equal to root over 34 minus 9, which is equal to root over 25, which is equal to 5. Let us mark it here, 5 meters, and this one is 3 meters. And let us remove this and just put whatever is necessary. Now let us consider the forces acting on the ladder. Normal reaction of the floor acting on the ladder is equal to N1, which is acting in the vertically upward direction. So normal reaction of the floor, reaction of floor is equal to N1, which is vertically upwards. And the normal reaction of the wall, normal reaction of the wall is equal to N2, which is acting towards left here. N2 is the reaction of the wall on the ladder. Weight of the ladder mg, we know that m is equal to 10 and g is also equal to 10, so is equal to 100 newtons, which is acting in the direction of PQ at the midpoint of the ladder AC. So P is the midpoint and it is acting in the vertically downward direction along PQ. Force of friction acting at C towards right. force of friction is equal to F, and it is acting towards right. Now we'll assemble everything here and remove everything else. So we have assembled the data. N1 is the normal reaction of the floor acting in the upward direction, and N2 is the normal reaction of the wall acting towards left, and mg is equal to 100 newtons, which is acting in the downward direction along PQ, and F is the force of friction of the floor which acts towards right. Now, since the ladder is in equilibrium, so for vertical equilibrium, upward force should be equal to downward force. Therefore, upward force is N1 and downward force is mg. Therefore, we can write N1 is equal to mg. We'll mark this as equation 1. And for horizontal equilibrium, force towards left should be equal to force towards right. Therefore, we can write N2, which is the force towards left, which should be equal to F, which is the force towards right. We mark this as equation 2. Now, reaction force of the wall, Fw is equal to N2. And there are two forces acting on the ladder due to the floor. One is the normal reaction and another is friction, which are mutually perpendicular to each other. Therefore, reaction force of the floor, Ff, is equal to N1 square plus F square. Because this is the magnitude of mutually perpendicular forces, N1 and F. And we know that from equation 2, F is equal to N2, so this gives us equal to root over N1 square plus N2 square. Therefore, the required ratio Fw by Ff is equal to N2 divided by root over N1 square plus N2 square. We'll remove everything and keep the only important equations. We'll mark this as equation 4. No, because we have equation 1 and 2, so this will be 3 only, equation 3. We'll keep these equations and remove everything else. Now we will take moments of the forces about the point C, bottom of the ladder. So for equilibrium, the clockwise moment should be equal to the anti-clockwise moment, so that the net moment will be 0. So clockwise moment is equal to mg, which is downward, about C. mg can rotate it clockwise. So mg into CQ, which is the perpendicular distance of this force from point C. It should be equal to an anticlockwise moment, that is N2 will produce the anticlock moment. So N2 into AB, perpendicular distance of N2 from the point C is AB. Now CQ is equal to L by 2 into cos theta and AB is equal to L sin theta. Putting these values, we get mg into L by 2 cos theta is equal to N2 into L sine theta. L gets cancelled. On simplification we get N2 is equal to mg by 2 cos theta by sin theta is equal to cot theta. This will mark as equation 4. Now in triangle ABC, cot theta is equal to BC by AB. Therefore, cot theta is equal to 3 by 5. Putting these values here, mg is equal to what? 10 into 10. mg is equal to 100. We can write directly 100. 100 by 2 into cot theta. Cot theta is equal to 3 by 5. So this simplifies to 2 becomes 50. So 5 into 10 is equal to 50. So 10 into 3 is equal to 30. So N2 is equal to 30 newtons. For equation 3, we need the value of N1 also, and N1 is equal to mg. So N1 is equal to mg, which is equal to 100 newtons. Therefore, the required ratio Fw by Ff. Fw by Ff. Fw by Ff. N2 is what? 30 divided by root over N1 square is how much? 100 square. 100 square plus 30 square. Now we can write 30 as 3 into 10, and here 10 square can come out common, and outside the root it will be 10. So 10 into root over 100 square becomes 10 square, that is 100, plus 30 becomes 3, because 10 square has gone out, so 30 becomes 3, 3 square is equal to 9. So this 10 and 10 gets cancelled. This gives us 3 by root over 109, which is the answer to the question. Therefore, the correct option is C. This completes the answer to the question. Thanks for watching.